Hi everyone, this is the introduction to Chapter 1, Electric Charge. This chapter could also have been named Electric Force, and this chapter lay down all the foundation, all the main concept we need in order to understand more advanced electric and magnetic concept. So let's dive into the main concept that we need to understand in order to be successful in understanding electricity and magnetism. So the first thing we need to talk about is there is two types of charge in the universe. There are positively charged particle, like the proton, and there are negatively charged particle, like the electron. Now, there's a couple of points I want to talk about, and the first two are related to the charge themselves. The first one is unlike charges attract each other. If you have an electron and a proton, they will attract each other. Positive and negative attract each other. Second point, like charges repel each other. If you have two electrons, which are both negatively charged, they will repel each other. If you have two protons, which are both positively charged, they will again repel each other. The third point is, over the course of many experiments, we were able to precisely determine the charge of a proton or an electron. And we use a letter lowercase e to denote that charge. And the absolute value of lowercase e is 1.6 multiplied by 10 power minus 19 coulomb. Coulomb, denoted with the uppercase C, is the standard unit for the charge. If we are dealing with electron, the charge is negative, therefore we need to add a minus in front for each electron that we have. Same logic with the proton, we add a plus. You don't really need to write the plus, but it is still there. And if you have many proton, well, you need to multiply by this value for each proton you have. Fourth point is conservation of charge. In the universe, charge are conserved at all time, all right? So this concept will be more used in when we are talking about circuit. Knowing that if we get to a branch in a circuit, the number of electron coming in has to equal the number of electron coming out will be a very useful concept, but we will use that one in a couple of weeks. Fifth point is the Coulomb force. So first, I want to talk about the absolute value of that force. So note, we are not talking about the direction yet. So the absolute value of the Coulomb force is equal to K, Coulomb constant. I'm going to talk about that one in a moment. Multiplied by the first charge, multiplied by the second charge. Now note these two charges could be negative, and you need to take into account the negative in this case. It could influence the direction also of the force. Divided by r squared. R over here is the distance between the two charges. All right. Now, one thing you will see, and I mentioned also that part in the vector section, is that might be confusing at the beginning. The way we calculate a force, we should calculate the magnitude of the force first, and after we look at the type of charge we are dealing with to determine in which direction the force is pointing. And you will see, I will do many examples with that concept. It will become more obvious while we are solving some example. But for now, keep in mind that to determine the force, we calculate the magnitude and we will look at the direction after. But again, with an example, it will be easier. Sixth point, the Coulomb constant. Now, the true value of the Coulomb constant is 8.988 multiplied by 10 to the power 9. However, since we are going to be using that number everywhere, let's just simplify it to 9 multiplied by 10 to the power 9 Newton multiplied by meter squared divided by Coulomb square. This number is much more user-friendly to use, all right? So we only use 0.2% of the answer. It's not a big deal, all right? Last part is the principle of superposition. So the net force on an object is equal to all the force that are acting on that object independently, just like you've seen in mechanics. So let's say you got 3 charge at different point, you add a fourth one, well that charge, there are 3 charge pushing on that charge, and if you want to calculate the net force, you simply deal with each of the charge or the set of 2 charge individually. Again, we will have many examples to highlight that concept. It can get quite complex, but we will get a lot of time to practice these. All right, so I'm done with the introduction to chapter 1. In the next few video, I'm going to be solving many examples related to this chapter. All right, so see you in the next video.